Hi.
My name is Kotachi Ada from YUMIN Primary School.
I'm GUO CHENGXI 11 years old, grade 5, also from YUMIN Primary School.
Now we'll continue with
Differential equations. Chapter 1. Separable differential equations. So for this time, let's just have this as one example.
Okay.
And before that, what did we learn last time? And the last
lesson we only have until C, right?
Wait, do you still remember about our acceleration?
Yup, which equals to limit delta t equals to approaches to 0, I meant, and delta.
Remember, for A is for V.
Delta V over delta T, which equals to dV over dt, which equals to d square x over dt square.
Okay, yes. So for this part, what is it? You know that we can write it as, okay, take this as an example. So if this is our example, it will be like this, right?
Yup.
Or
Also the same.
but right now, what will we choose?
Plus, because this is not separable.
Well, this is actually the second order, which we haven't learned how to solve right now. But remember, of course, we'll learn this in the future. Okay? So for this, we'll choose this, okay? Right now. Okay, so this is just for an introduction, or like the acceleration. Okay? Well, actually, it's not really the introduction, it's just like a revise.
Okay.
Okay, so far for the acceleration, are you clear?
Of course.
Okay, so for this question, which is, there is a particle.
Travel in a straight line, and it takes 10 seconds after passing a fixed point P on the line. Which line?
The line that a particle is traveling.
Yes, and on the line, its velocity v cm per second is given by the velocity equal to t bracket 4 minus t squared bracket.
Okay, so we need to find, firstly, the acceleration of the particle 3 seconds after passing P.
Secondly, we need to find the distance of the particle from P 2 seconds after passing P, given that the distance from P is atm when T is 1 second.
Okay.
C, which is displacement in second.
Remember,
D,
this second is second number 2.
Yes. And D, which is distance from T equals 1 to T equals 3 seconds. E, which is displacement from T equals to 1 to T equals to 3 seconds. F, which is position when T equals to 3 seconds.
So remember, for this time, you must be very sure the difference between distance, displacement, and the position.
Okay.
Okay, so we can have our first, which is the acceleration of this particle.
Okay.
So for this acceleration, remember we need to use what we wrote just now, right?
Yeah.
Do you know how to solve for this?
Okay. So acceleration is differentiation of the,
Remember, it must be v,
which is,
the velocity,
yes,
with respect to the time.
so here, which is,
Remember, you can times this in. Wait. Remember, it is a differentiation.
like this.
And remember, the time is 3 seconds.
So t equal to 3, then become 4 minus.
Remember, there are also need, and here we actually can have a bracket also. Well,
And don't, because that here there's no t's, right?
so there will be. Remember, this is a 3 cube. Yes, 27.
So 26.
And your unit?
And it's a negative. Here was square because it's acceleration.
Yes. So next for this part B, which for this is the distance. Well, this time we actually need to draw one thing. A graph. For
Okay.
example, this direction, it is t,
Time.
and this direction is v,
Voltage.
not voltage, velocity.
Yeah. Velocity and voltage are different. Voltage is another thing which is electricity, and velocity which is over here physics. So here negative 2,
Why? Why you need to mark out those?
here.
Okay, so this is when you sub in 2, this is a 0. When you sub in negative 2, this is a 0. When you sub in 0, it's also 0. Okay, so that is actually an inverse n, right?
And which is actually like thus,
So
and
remember,
inverse n which is
you actually need to sub in these sometimes to make sure about them, right?
actually this is something like from very fast to slow to walking backward faster than slow, then walking in front faster than slow, then walking backwards faster.
Okay, so right now for this, well, remember, we're already given when the time is 1 second.
Okay.
So 1 second starts from here,
Okay.
right? So for this, our integration will find the area. Am I right?
Yup.
So for this part B, first we already know that it is from the 8 to.
Okay, I tell you something. N is for 3 points. Maybe in the future there will be an N. Which is 4 points. Okay, so first it's just like a something like this. Oops. For example, something like then after like the 1 point, then we have 2 points, then 3 points, and in the future there could be like this. Put it the M in 3.
Okay, so right now for this part, we're not talking about these anymore, okay? So,
Okay.
over here, do you know why is it like this? Do you know why? Well, this is how we integrate.
Yes,
so here,
we
it
use
is from 1 to 2. And remember, we go like this.
We use the definite integral because that for the indefinite integral you still need to find the c.
Yes, and remember for this is always from this curve to 0. So that's why I don't have that 0 anymore. And remember, this is the curve.
Yep.
Right? So for this, what is this actually? Do you know what is that? So we just need to integrate. So for this, we have. So for example, if we subtract in a 2 here, it's actually 8 minus the 4, right?
Of course.
Then if we subtract this 1, which is actually minus, so it's the 2 minus 2 plus the 1/4.
Okay.
So when the minus 2 plus 1/4 is actually a 2 and 1/4. Right?
Yeah. Wait, but that's not the answer yet.
Well, this is.
That's not the answer.
Why? So actually for this,
Cm, still have the Cm. It does that you need to shift the
so remember,
there would shift the 8 there, which is still an 8 because everything was a negative 8.
so for this, would you need to plus an 8 on the other side? Do you?
Yup.
Wait, are you so sure?
Of course.
Wait, but remember for this, here, okay.
Erase here. Faster, just write what x equals to. Just write
So
what x.
next is the part C.
Wait, we haven't finished part B yet. Because this, which is x plus x minus 8, so we need to shift the negative 8 to the other side, which become a plus 8. Let's shift. Okay.
Okay, so I was saying that because that this is actually the distance.
Yep.
So is it like this?
Yeah.
So next, part C.
Part C, easy. Actually, in that part.
Displacement in the second, it is. Which part you say? Here. 2 and 1/4.
Yep.
So just write it down. Remember, you need to write this equals.
Need the x minus 8 because then we can't shift it. Shift it, I meant.
Okay, so are you sure that you write it like that for part C? displacement, right?
Yep, you don't shift the negative 8 part.
But remember, you usually write it in the integrals form.
Already integrate.
So this is actually for C, right?
Yep.
So for the D, remember we are finding our distance. And here when it goes, and then this become a negative, so then it come back. So that means we cannot straight away from 1 to 3. So for this, integral of course is from a to x. And then here is first from 1 to 2. Here is the curve minus the line. Curve is the like this, right? So minus 0 no need. Like this. Then after that, you have to plus
the line.
Here from line to curve. 0 minus this, right?
Yup.
So it will be like this.
Okay.
And then after that, so we just integrate, right?
Yes.
You still remember what we got from this? It's a 2 1/4, is it?
Okay.
So remember for this, when you sub in the 3 for this part, well, what is 3 to the power of 4? 81, right?
81.
So 81 over 4. Then here, you minus how much? Remember, here's a minus 18.
Okay.
Then minus a 4,
Yes.
which is already a minus 22, right?
Yeah.
Then you plus an 8, which is a minus 14. So just calculate this. So remember, this is already a 20 1/4. So when you minus 6, so 8. And remember, 1/4 and 1/4 becomes 1/2.
Yes.
So it's like this. This is for part D.
Okay.
So next, which we have our part E. So part E, we find our displacement.
We could actually just write it one term.
Okay, yes, because this counts everything. This positive part and the minus part.
So we need bracket because both sides also need now. Just now because that one side over here no need.
So remember this from 1 to 3. So first here, which you have an 18, right?
Yes.
Then here, which is the minus 81 over 4. Then remember, here's a minus 2. Plus 1/4. So remember for this, here is 20 and 1/4. 1/4, 1/4, they cancel out. So that means it's 20, right?
Wait.
Minus 20.
Yes.
So here we come minus 2.
First.
Minus 2 minus 2. So that is just a negative 4. And it will be centimeters. But what does that mean? You know what that means? It means it went back.
Yeah.
Right?
It began walking backwards.
Yes. So this is actually just for part E, right?
I thought you may think, of course, going in front, but then it came out to be walking backwards.
So next we have our F.
Okay.
So for this F, remember it is now the position.
Yes.
This is the position when T is actually at 3 seconds. So when it is at 3 seconds, well, we also use this, right? Because we want to find out where is the final position. Am I right?
Okay.
So for this, remember this is a, when you integrate, it's a x minus 8. And this is, what is that? A negative 4.
Negative 4.
So we actually just need to move the 8 to the other side. And it's actually just like that. So remember, position is final. And for these distance, displacement, they all have where it is. But actually position they also can. But it's just that it is at the last second. Or unit time, because it might not be second, it might be days, it might be minutes, it can be any time, right?
Yeah.
So for this, well, that is actually all for these A, B, C, D, E, F, right? So for all of these, are you clear so far?
Yeah.
So anything else to say or ask?
If you like our video, don't forget to subscribe to our channel.
Okay, so stay tuned for more videos.
Our adventures.
We'll see you in the next lesson.
Okay.
And remember, this is differential equations.
Okay.
So see you in the next lesson.
Yeah.
Thank you for your watching.